So basically, here are some guidelines for teaching fraction computation. The first thing I'm going to say before we start with number 1 is you need to know how to add, subtract, multiply, and divide fractions. If you do not know how to add or subtract or multiply or divide fractions, then you've got to learn how to do it. There's no way that you can show your students how to do these operations with fractions unless you are good at it. I suggest going to Khan Academy, doing a lot of practice, looking up some other videos, getting some practice doing these operations with whole numbers, fractions, improper fractions, fractions with like denominators, and fractions with unlike denominators. Then you will be able to teach fractions. Only when you know how to do them can you teach them. When you are teaching fractions, it's important to begin with story problems. The kids need to know how this actually works. What do we use fractions for? And if you're just giving them a problem out of a book and it doesn't make sense to them why they're using it, it's not going to work. Use story problems. Put those fractions in context. Next, connect fraction computation with whole numbers. How do we add whole numbers? It's the same way we add fractions. With whole numbers, we don't add numbers in one language with numbers in another language. We've got to get them in the same language. We've got to know what they're saying. It's the same way with fractions. They have to have the same denominator in order to be added or subtracted. So let estimation and informal methods play a big role in the development of strategies. Don't start with the algorithm. By all means, do not start with the algorithm. Let the students play with it, understand how to add and subtract fractions through a conceptual basis, and let them think through some estimation. And then, of course, explore each of the operations using models. So here are some examples of some contextual problems you might use. And here I would have the students just draw it out, use a model. Don't start with that algorithm. Have them draw out these samples. Again, use contextual problems, something that the students can relate to. Now let's talk about addition and subtraction. First of all, when students use modeling and learning through concepts, they're going to begin with their own invented strategies. Let them do that. It will really help them to understand the algorithm in the long run. It's really important to focus on equivalency. That's those common denominators. So finding, not through the algorithm, but through pictures, the students need to find those commonalities. So here are some ways that can be done. If you're adding 3/5 plus 1/2, there's the picture at the top. Find those common things. Find the common denominators through those pictures. So if we take 1/2 and we take 3/5, actually I would turn that 1/2 sideways so that that picture was going horizontal, and then you can actually see how you can divide the fifths right in half and end up with 10 pieces. So you would have 6/10 plus 5/10, and they would eventually see that that's larger than 1. Here's another one, 3/4 plus 2/3. So here they've used common denominator of 12 because look at the rows. There's 4 rows going across, or 4 columns going across there on 3/4. 3 of those columns are shaded. That's the 3/4. And then you have your 3 rows going across for 2/3, and 2 of them are shaded. Now we can add 9/12 plus 8/12. Here's subtraction. Same basic thing. Starting with the 5/6, showing them that we're subtracting half of that. 5/6. Half is the same thing as 3/6. We take it away. What's left over is 2/6. So with multiplication and division, you have to know that a lot of people just don't understand multiplication and division of fractions. The reason why is because generally when you multiply by a fraction less than 1, you're going to get a number that's smaller than what you started with. And kids have always understood that adding and subtracting you get a larger answer, but not with multiplication of fraction. And then division, if you actually divide by a fraction less than 1, then you're going to get a number in the end that is larger than what you started with. And that really, really confuses the students. So you have to use a variety of contexts and models. So how do we develop an algorithm for multiplication? Well, we look at the problem, 3/5 times 3/4. This means 3/5, okay, something that's not yet 1, of a set of 3/4, okay? So to get the product, look at there, we're going to set up 3/4 first, and then we're going to take that section and take 3/5 of it. So you can see the pictures, and then the region where like the color overlapped, that's the answer. So it would be 9 out of 1, 2, 3, 4, 1, 2, 3, 4, 5, 9 out of 20, 9/20ths. Yep. And if you multiply straight across, you get that same answer. Division, really difficult to understand. How many sets of half are in 5/3? Okay, so we restate the problem with common denominators. We're going to try and find these common denominators in 6. We know that half with 6 on the bottom is 3/6, and we know that 5/3 with 6 on the bottom is 10/6. So we're going to go ahead and we're going to make sets of 3/6 from the 10/6. So we have 10/6 written down there. Now how many sets of 3 can you get out of them? Well, you can get 3 and 1/3 because you have 1 left over. That's kind of tricky. Really look into the division of fractions to make sure that you understand the modeling of this. I put some videos up and a reading that I think will really, really help you. There's 2 teaching videos, the one with borrowing, the one on the far left, and the one on the far right, fraction multiplication. And the others show you different ways that you can model fractions with addition, subtraction, multiplying, and dividing. These are ways that will help you learn to teach and probably help you learn to understand it a little bit better. Enjoy this week and learn to add, subtract, multiply, and divide with fractions.